All right, so first of all, in yesterday's section, we talked about like the two different to start with. The two different types are exponential and log, right? And the log, so like number 2 and number 3 that have ln or log in them, these are the ones you want to check. So if it was me taking your test on Thursday, I would put a little star next to everything that's a solve a log equation so that it reminds myself to go back and check those questions. Why aren't you working? Let's go. So I would know to go back and check those. Same if it had an ln, like I would put a star, put something to remind you. Not when you're just simplifying, obviously, but the ones that have an x in it, when you're solving, you got to make sure you check. So with number 1, we don't need to check it because it's exponential. So then there's two types of exponential. Can I change the base to be the same? Obviously, I can't do that with an e. So then the other one, which is like this, we want to solve for whatever's raised to the power. So I'm going to add the 3. I get 2 to the x equals 13. I want to divide by 2. So that just the base with the exponent is isolated. And then I want to ln both sides of this equation. So I ln and I ln. If it was a base other than e, then I would bump the exponent to the front and I would divide by what's there. But because it's ln of e, this cancels and I end up with x equals ln of 13 over 2. And be careful how you type that in the calculator because the 13 over 2 should be inside the parentheses. So I want to find the ln of 13 over 2, not the ln of 13 divided by 2. And then this I get 1.8718, which rounds to 1.872. Questions on that one? All right, then I go to 2. So 2 just says log. What's the base on that log? 10, even if it doesn't have it, or if it doesn't have it, it's 10, right? If there was something added or multiplied on the front or something, I would isolate the log first. This one's already isolated, so the first thing I'm going to do is do 10 to the second, and that drops off. And I get 100 equals 4x, and then divide both sides by 4, and I get x equals 25. And then I check. So when I plug 25 back in here, does what's next to the log, is it 0 or negative? It's not. If it was, I would rule it out. It's not, so I keep it. If this was, so this question did not need to be on the calculator portion. Like if you're trying to separate out in your brain, number 1 would be on the calculator portion because it's actually asking you to find something, you know, ln. Number 2 would not. So be really careful with that kind of stuff. And then number 3, I've got more than what log on one side of the equation, so I'm going to condense it first. When we add and we condense, what happens? Good. It would be 5 times x plus 2 equals log base 3 of x plus 5 or plus 6. And then at this point, there'll be two different types. Either like it is here where there's one log on either side of the equal sign and we literally ignore the log. And I'd get 5 times x plus 2 equals x plus 6. 5x plus 10 equals x plus 6. Subtract the x. I get 4x plus 10 equals 6. Subtract the 10. 4x equals negative 4, and x equals negative 1. And then I check it. If I plug a negative 1 in here, it ends up being log base 3 of 5, which can be done. If I plug a negative 1 in here, I end up with log base 3 of 1, which can be done. So we don't just rule out every negative answer. We rule out the ones that when we plug them back in, the log would be of a negative or of 0. So this one I keep. The other type of question you had with this would be like if it said log base 3 of 5 to the x minus 2 or x plus 2 and it equaled a number. And in that case, so like if there was just a number over here, then I would convert it to exponential. That would be 2 squared equals x plus 2 or 9 equals x plus 2, which is x equals 7. And then I would check. So 2 different types with condensing. Condensing, and you end up with 1-to-1. Ignore the logs. Condensing, you end up with just one log on one side, and you convert it to exponential. Questions on anything like that or from yesterday? All right.
Did you just do that last section?
Yeah, like if it hadn't had this on the side and it had 2, one side condensed it, there's only a log on one side, so we convert it to exponential. So the 3 picks up the 2, the log drops off. Okay, so let's go through what is going to be on your test Thursday, sorry. It is 20 questions. A good portion, I want to say 13 of them are multiple choice. 7 are calculator based. Actually, I think even more than that, 13 are multiple choice. I haven't made your answer sheet yet, but I think the first 4 are open-ended calculator, then there's 3 calculator that are multiple choice. So 16 of them, 16 of them are multiple choice, which can be a good and a bad thing. So just be really careful when you're making your choices. Like if it's a plus and minus and it's not supposed to be, or if it's a no solution and it's not supposed to be and you pick the wrong thing, that's where a multiple choice is going to get you because there's no partial credit. But hopefully it will help you out if you're completely off. Your answer won't be there, which would be the good thing. So it starts, your test will start with the calculator portion, but it kind of mixes in through the sections. So it's not like all of the beginning is on the calculator. I put 3-1 on here, but really it's not a 3-1 test. It's just that that part of 3-1, the 1-to-1 part, came back in 3-4. So you saw it again in 3-4. But really 3-1 itself is not in. Like the graphing of the exponential functions are not on your test. 3-2 is when we got introduced to all those log functions. So these are the ones you really want to know mental math-wise what these properties are. Log base 3 of 1 is what? 0. Log base 3 of 3 is 1. Log base 3 of 3 to the 5th? 5. 3 to the log base, that is a little 3, of 4 is 4. Log base 3 of 1/3? -1. ln of e to the 3rd? 3 and e to the ln of 4? These should be fast. Like that, literally, you should be able to do a good 3 or 4 of those questions in a minute. And then it helps you out with the rest of the time, okay? So be really careful with that stuff. Questions on those? Okay, then you get the graphs of logs. So it's actually a multiple choice question. You should be able to do this easily if you know what you're doing, okay? But you could get a question on the logs, and it could be on any of those. It could be what's the graph look like. It could be what's the vertical asymptote. It could be what's the domain, that kind of thing. So make sure you know how to do it. So if it said f of x equals, even if it said like, I don't know, log base 6 of x minus 7, without doing any work, you should be able to identify your vertical asymptote. Where would it be? X equals 7. You should be able to find your y-intercept because I could convert this. This would be 6 to the y equals x minus 7. 6 to the y equals, 6 to the y plus 7 equals x. And if I want the y-intercept or the x-intercept, I plug 0 in for y. So I get 6 to the 0 plus 7, or 1 plus 7, which is 8. So I should be able to get the x-intercept relatively easily too. And then if from there, if it was multiple choice and you can't make your selection, then maybe you plug in some extra points. But I really think if you know how to do your vertical asymptote and your x-intercept, you should be able to get your graph of your log from that multiple choice part. You're actually not going to have a graph of an ln in which you have to completely graph it, but it could ask you for the vertical asymptote or the x-intercept or the domain or anything like that from the ln. So just be prepared for that. So domain here, remember, it would go vertical asymptote, which is 7 to positive infinity. Questions so far? All right, then came 3-3, which was condensing and expanding. So if it said log base 3 of a times b, when you expand that out, what's it look like?
Log base 3 plus log base 3 of b.
Good. Log base 3 of a plus log base 3 of b. Addition becomes multiplication becomes addition, or addition goes to multiplication if you went the other way around. It's okay. Why don't you write it down and I'll keep you awake. Log base 3 of a over b. If it's division, it becomes what? Good. So log base 3 of a minus log base 3 of b. And if it's raised to the exponent, what happens to the exponent? Bumps to the front. So b log base 3 of a. So a question could have it expanded and ask you to condense, or it could be condensed and ask you to expand it. Just be prepared for both. We talked about change of base in 3-3. So this is where I would want to be able to rewrite either as common logs or natural logs. If it said log base 5 of 2, this would common log be log of 2 over log of 5. natural log ln of 2 over ln of 5. With a calculator, you would actually find it. Without a calculator, you'll just leave it as that ratio. Questions so far? Okay, and then it will feel heavy 3-4 because so much of that comes back again. Like part of this was in 3-1, but it really kind of loops it all back together. So in all these equations, remember there's two different types, exponential and then log. If log's in it or ln's in it, that's the ln. Anything else is exponential. So first thing I would see is, can I change the base to be the same thing? So for the first one, can you change those bases to be the same? Yes, 8 could be 2 to the third. And then as soon as the bases are the same, we ignore those bases and we set the exponents equal to each other. And then I would solve for x. If you have no idea what you're doing, then a multiple choice question like that, you could plug in your answers, okay? It's faster usually to solve it than it is to plug it in. So I wouldn't waste too much time. But if you're confused or you're doubting yourself, you could always check those answers. Yep.
Is it multiple choice?
Most of it is. Yeah, not all of it, but most of it is. All right, then I get one with an e as a base, right? I can never change e to be something else. So I would divide both sides by 2. I get e to the x equals 11 over 2. And then if I can't change it to have the same base, you do what? ln. So I ln both sides of this equation. ln of e cancels. I get x equals ln of 11 over 2. They all say 3 decimal places. Yep.
Could you also convert it from that form into like a log form, and instead of writing log base e, just write ln?
Say it again. Like bump this?
Yeah, so like bump the e down, replace the x with the 11 over 2. Like the way you convert it from exponential.
Yeah. Oh, yeah, yes. Like from ln of e, make it log base e?
Yeah.
Yes, of course. Yep. ln of e is just shorter because it cancels out, gives you the exponent. But can you convert it to exponential? Absolutely. Yep. All right, then 5x equals 4. This is a case, obviously, we can never make 5 become a base of 4. So we ln both sides of this equation. The x bumps to the front, and I get x times ln of 5 equals ln of 4. And then to isolate the x, I'm going to divide both sides by ln of 5. So I get x equals, and then this one we carefully type in because you got to close the parentheses after the 4. It would be ln of 4, close your parentheses, divided by ln of 5. Or you can put it in fraction form, but 0.861.
When is it that we have to check it?
When it starts with log or ln. So if it doesn't have log or ln at the beginning, you're just finding the answers. But if it says ln or log in the question and then you're solving, not just expanding or condensing, but solving, that's when you're going to check. Okay, then I get here, and remember on yesterday's video I said, like, these look weird, but they are the same thing every time. If you've practiced this and you know what you're doing, it should become second nature because it's the same thing every time. I can rewrite this as a squared plus 3a minus 10 because I'm going to make a e to the x. Then I'm going to factor it. So what are factors of negative 10 that sum to positive 3? Positive 5, negative 2. Then I'm going to split and solve it. So a is negative 5 and a is positive 2. And then I bring the e to the x back in. So e to the x equals negative 5. E to the x equals positive 2. And then I ln both sides of the equation. The ln of e to the x, the ln of e cancels. I get x equals ln of negative 5. And x equals ln 2. What's going to happen when you try to ln negative 5? It's going to get an error. You can't find the log of a negative number. ln of 2, 0.693. If they were both positive, if like when I factored they were both positive, I'd have two answers. But obviously if one is negative and I go to ln it, your calculator will yell at you. Questions on any of those exponential ones? So same base, if not the same base, lning both sides. All right, then all the logs and all the log equations you have to check. So again, if it was me, I would go through my test and I'd put a little star or something next to every time you were solving a log or ln equation so that you remember to check. So if there's only one log or ln, then we're going to convert to exponential. That's the left side here. So if it said log x equals 2, this is really log base what? 10, good. And then the 10 comes over, picks up the 2, and I get x equals 100. And then I check. If I plug it back in, is what's next to the log bigger than 0? It is, so I get to keep it. So that could be non-calculator. ln of x becomes log of what? Log base e of x. And then it becomes e to the second equals x. And e to the second is 7.389. And I check. If I plug it back in, I'm finding ln of something bigger than 0, so I get to keep it. Still good? Yes? Good? Okay, then I get one log on both sides of the equation, and this would be your simple one-to-one. So this could look like log x plus 3 equals log 20, something like that. If they're the same log on either side of the equal sign, I ignore it. X plus 3 would equal 20. Subtract the 3. X equals 17, and I check. If I plug it back in, am I finding log of something bigger than 0? Yes, so I get to keep it. Still good? Yeah? Okay. If there are multiple logs or ln's on one side of the equal sign, then I have to condense. So we're going to use our rules of condensing. So if I look at that first one, log of x plus 21 equals 2. When I condense this down to one log, what happens? Good. X times x plus 21 equals 2. Now there's only one log on one side, so I'm going to convert it to exponential. You can either distribute and then convert, but at some point you have to convert it to exponential. The base on the log is 10. So 10 comes over, picks up the 2. 10 squared equals x times x plus 21. So 100 equals x squared plus 21x. Then I'd subtract the 100 because I have an x squared and an x. I know I'm going to have to factor. 0 equals x squared plus 21x minus 100. What are the factors of negative 100 that sum to positive 21?
25, 4.
Good. 25, negative 4, split and solve. And then we check it, right? This time if I plug in negative 25, I'm going back to the original. I plug in negative 25 into those places, and both of them would be a problem. But if either one was a problem, I would eliminate it. And then I check for the 4, and in both cases 4 works, so I keep it. This is what I'm talking about. This is where like a multiple choice could really get you, because one of those answers for sure would be 4 and negative 25. Don't get excited, circle it and move on. Be careful and make sure you check those answers.
So you would put no solution.
No, you would put 4. If both canceled out, then it's no solution. Yep. Okay. Yeah.
So does it have to
All right, this time when I condense, what's going to happen? Divide. So x over x plus 2 equals log of 2. If there was just one log, so like if only the left side had the log, I'd convert it to exponential, but it's not. They're both there, so I ignore the logs. And I get x over x plus 2 equals 2. I would multiply both sides by x plus 2 to get it out of the denominator. I get x equals 2x plus 4. Subtract the 2x. Negative x equals 4, and x equals negative 4. And then, what do you gotta do? Check it. If I plug the negative 4 back in, can I keep it? No. Again, even if it was just one of those that it was a problem, I would cross it out, but it's both. So this would be a no solution. Okay, last one. We're condensing again, and this time it's minus again, which means division x over x plus 3 equals 2. And this time I only have one log, right? I have an ln on the left-hand side. So I'm going to convert it to exponential, but ln becomes what first? Log base e. Then I convert it to exponential. So e to the second would equal x over x plus 3. I can do e to the second now, or I can save it. It doesn't matter, but I'm going to round it to 3 decimal places. That e to the second is 7.389. Then I multiply times x plus 3 to get it out of the bottom. $7.389x plus 7.389 times 3. Oh, man. $22.167 equals x. Subtract the 7.83. No. Yeah. 7.389x. God bless you. And then divide both sides by negative 6.389. And I get x equals negative 3.469, so 470. And then I go back and check, and it wouldn't work in either of them. In the first one, it's a problem, and in the second one, it's a problem. So this whole big, long thing becomes no solution. Because ln is log base e. So unless there's an ln on both sides of the equation, you're going to have to convert it to exponential. And before you do that, you got to rewrite ln as log base e. So log becomes log base 10, and ln becomes log base e. And here's the thing, like I would say there's going to be some that like you get hung up on the test. You have to skip it. Skip it, find something easy. There's going to be easy, I promise you. Find the easy. Build up your confidence. Then go back and go back to the hard. Yeah.
What if it only wasn't, like it didn't work on the x plus 3?
Immediately you ignore it.
And no
So
solution.
even if it's not good on one, but it's okay on the other, it becomes no solution. Yep. If it doesn't work for either of them. So if it was like a negative 1.5, it's a no, because it doesn't work in that first one, even if it works in the second one. Yeah. Questions? Okay, you have to do your review tonight. Like, it is your homework. You need to come in tomorrow with your questions to know what you know and you don't know. We'll do some extra practice, but this is your opportunity to really understand what it is that you need help on and what you don't, okay? Overall, what do you feel like you would get extra practice on tomorrow on?